So following up on our introduction to assignment 2, we're going to have a look at another game controller that's already been made and modeled up. That is the Steam controller, just a Steam controller. It's a relatively new design. It's got, It's got touchpad, haptic feedback. Anyway, interesting shape, and the files for it are available online. It's open source. You're meant to be able to develop with it. Which is great. So that means we can get the files and check them out. So what you should do is download this zip. When that downloads, you get a zip file. All you have to do is just right click and extract. Then you can open up and you've got all these options for files in here. Now, these are .g files. That doesn't really make a lot of sense to us. So what we really need to do is find a way to adjust them so we can use them in Fusion. Now, there's really easy options in Fusion to do this. Let me bring over Fusion. And what we want to do first is to just create a folder for game controller or our assignment. And I'm just going to make another one for the Steam controller as well, just so we can keep everything nice and organized. What we then have to do is upload all these files. So if we go select, here we have our Steam folder, and we have to select the files. We don't want the XML or the DS file, so what we can just do is sort by type, make sure we get everything that's a G file, and go open. It then comes up with this issue or thing where it needs one top level assembly file. What that means is it's looking for a file to organize everything. If we have a look, we can find it as Steam Controller Workshop 03. It's only 5 kilobytes. Don't ask me why it's called that, it just is. So we select that and we hit upload. So now we can see it's just uploading in the top, and that may take a second. Oh, it's uploading across here. Okay, so once that's uploaded, we can hit close, and we want to try and actually open this, whatever's uploaded. We double click. It might take a second just because now it has to download all the files that have been uploaded and shove it into one part. So don't be worried if it looks like your Fusion's crashing. Mine looks like that all the time. Sometimes it crashes, sometimes it doesn't. It should be all right. We can see the last thing it was trying to do was open the document, and it looks like it's working. All right, so it's loaded in these files, which we can see are 3D CAD files for the Steam controller. I'm not quite sure why the blue and red are there, but what we're going to do is actually just change them up so we can better see everything. So what we can do is hit A on your keyboard, or we can just go to modify appearance, and what I'm going to do is just apply a basic paint to the surface. Let's go with green, why not? And we'll just hit remove to get all the applied details off. And now if we try and apply it here, it's not going to work out because you can see we've got this this sort of beigey yellow color going on. So if I drag the green onto it, it doesn't actually work. Now, this is a common thing you might come across in Fusion, especially when working with forms. So I think now's a good time as any to talk about it. And what we want to do is edit this component and move into the sub-assemblies as we go. And it looks like the part's fine, but what's really going on is, see, we have a surface here. So that means the part is open, it's not sealed, which is just what happens when sometimes you're bringing things that are designed in other programs across. You might find that if you make something in Rhino and Grasshopper and you bring it across, the surface changes up. It's not really a big deal in this situation, especially because we're not going to be manufacturing this. However, just to get around this, when this happens, what has really happened is we're looking at essentially the B side of a surface. So each surface has, well, two faces, an inside and an outside, and there's a A and a B side pretty much. So if we go into surface, because obviously we're modifying a surface, and go to reverse normal. So when I say A and B side, the A side is the normal side and the B side's the back side. It's just used sometimes for calculating appearances, saving processing power. It doesn't want to render things on the B side. So when we click that surface, it's all one big face. We go OK, and now it's flipped it the right way out, and our appearance is working properly. So we can see here that that backside, something weird happened with the trimming when importing it. Not a big deal, but just keep that in mind if you're trying to texture up something and it's coming out as just that constant yellow color. That means the normals have been reversed. So we have the same problem here and we have the same problem here. So we'll just fix those by going to modify, reverse normal. You can select them both at once. It doesn't matter that they're part of separate parts. And we'll just go OK. And now they both look a lot better. Disregard that, doesn't matter. So this is the Steam game controller, and it's great that it's at the right scale. It shows details of the ports, it shows the buttons, and everything can be broken down really well. So we got to consider what we're going to be modeling. This knurling on the thumbstick, maybe we could model it in, but it might take a lot of effort where we could just use a decal. We want to observe how the part line works. So that's a really important part of this project, is looking at the part line. So if we have a look from the side, we see that it kind of looks like just a regular sweep through shape here. But once we move to the back, we can see that it then comes up across here. So we can't just split it simply. We have to use a 3D shape to actually do that, and we'll probably get into that in the next video. So what can we do? What can we learn from this? Obvious things is overall size can definitely help trying to go from point to point and figuring out how big this thing should be. 120 across roughly, or from that point to that point. Apparently that's a good measurement. So if you don't have a game controller with you, you can base it off some of these. Obviously, if you do have a controller, I assume a lot of people would have PlayStation or Xbox controllers. You can use those and just to get a good idea. What we can also do is inspect the surface. So right now we can see we've got really nice sleek surfaces where the highlights run off really well and everything looks quite nice. Obviously nothing on this being a production level CAD file, nothing on this should be bad or weird. It shouldn't be janky in any of the surface transitions. It's all pretty smooth and nice. But we can have a further look at it there's two ways. We've got the zebra analysis, which you may have seen from SolidWorks, where you can see how these lines transition from surface to surface. And like down here, it's absolutely fine that it's, a sharp change there because it's going from a smooth surface and then jutting up. What's important is these sections here transition into themselves smoothly, and they're pretty good. This isn't the high quality. When I turn the high quality on, it should look a bit better. And yeah, now those surfaces look much, much smoother. So that's one way of looking at surfaces. The thing is, though, it tells you if they're smooth. It doesn't really tell you a lot about the sort of makeup of the surface. So if we go to Curvature Map Analysis, we can select this top body. This might take a second. All right. So we get this really weird sort of breakdown of the surface. What we want to change it to is principal maximum. So right here shows us where the largest areas of curvature are. And if we select the bottom, we can get a much better look at the whole overall design as well, because this is modeled up as one shape and then it's split up into its top and bottom pieces. All right, so we've got it now, and we can see the areas where we have a lot of curvature, and it kind of helps guide our part line in some areas as well. That's something to take note of for later, but you know, even just looking at the shape, you can see certain things about how you want to manipulate the curvature to suit the part lines. So right now we can see that everything here is coming off at this direction. That's kind of what's called a draft angle. So if any of these elements were poking out here, you would have problems with overmolding and your part would get trapped in the injection mold it's made in. We can go over that when we're actually modifying our parts a bit more, but it's important to note that generally you wanted to approach the part line and then move away from the part line with like a vertical line between them. So we can use this curvature analysis, see, yes, it has to have a nice big curved area around the hands, but the top of it is relatively flat with smooth transitions. That's because, you know, it's a controller where we have to be quite dexterous. We have to use our thumbs and fingers to actually control everything that's on here. So, you know, the buttons, you want them on a flat surface so they're easy and simple to read. Same with these thumb pads being flat. You want them to come off a surface that's relatively flat as well. So let's just get out of that. What we can also do is... All right. So yeah, what we can also do is hide some of the casing. This has a lot going on, right? It's got the whole PCB, every little hole and screw for it, controllers for something, whatever that is. Anyway, there's too much going on the inside of this. We don't expect you to model like every little fillet and knurling on that separately. That can just be, you know, consistent. What I do like, however, is the way they've modeled up the buttons. So the way buttons are actually made on a controller, let's find it. It's button B1. Okay, so the way buttons are made on a controller are two pieces. You've got a little inside component and the outside component. So the inside component is generally like if you think of a PlayStation or an Xbox controller, where you've got the X being blue, the circle being red, triangle being green, and the square being pink. What they have is a whole component in here that is one solid plastic color, and then the outer part, which is generally a grey plastic or something like that. The reason you do that is because when you spend hundreds of hours using these controllers, eventually the thumb starts to wear out some of the plastic. However, no matter how much you wear this down, that B being green button is going to continue to go down with the rest of the controller. It's just an easy way to print things up like that. They do it on high-end keyboards as well, with printed through buttons like that. So if we get back to where we were, and again, the Steam one for some reason comes through textured, maybe that's more important, but it's the same sort of deal, the plastic and then the label. Oh no, they've actually got it as a sticker on there. Good for them. So we can do things like that with splitting bodies, embedding our logo onto the front face. And then thumbsticks. Obviously you can see this is relatively simple to model up the form. I think that knurling's a bit excessive, but like these inside bits here, we can see this is where it's meant to grip a controller for a thumbstick, like the actual little component that measures pitch and yaw. We're not going to get into that. We don't need to go to that extreme. But modeling up the basic D-pad will work fine. Speaking of what we're actually going to be modeling up, there's a lot of weird controllers out there. So if I can just pull up a window on game controllers, we can have a look at all the ones that have sort of been made or concepts. The most common type of thing is something like, your PlayStation controller or an Xbox controller, where it has a D-pad, which is a directional pad. It has 2 joysticks, 4 face buttons. We got the 4 face buttons on the Switch. So what they call a shoulder button. So you hit them with your index fingers, and there's generally shoulder buttons and triggers as well, which are sometimes harder to see. And we could probably just see them on here. So here we have the shoulder button, this large section up here. And then down here we've got what are called the triggers. So they're usually sensitive to a certain amount of pull for things like racing games, applying throttle and all that. What we can also see if we go and inspect do a cross-section analysis or a just called a section analysis. Right, we have the option to select a face. What this is going to do is split the controller down that face. Hatching is really useful sometimes. It can help you pick the difference between one component and another, and it just kind of looks cool. So we can turn that on and have a look. What we're actually looking for right here in terms of what's relevant to us for designing a controller is the wall thickness. So this one's actually quite thick in its main section compared to some of the other controllers I've seen. Maybe that's why they didn't do so well. The cost was too high or something like that. But generally you'll find controllers aren't more than 1.5, 2 mil thick. What do we got here on its face? Okay, so that was, if we look over here, wherever it's going now, yeah, 2.59 mil, that's not too thick, that's pretty good, but generally we'll probably see about 1.8, and that's probably what I would recommend for when we do our offsets or our shelling to actually hollow these out. And we can see that applies to over here. We want to make sure it follows all the contours. And we can see that it has a groove where the 2 pieces can snap onto each other, and let's just close that and turn off that analysis off. And then it's got actual holes in the bottom where the controller can be held together by some actual screws. So we don't have like a snap together on the groove on the inside. What it does is kind of just holds it in place and lines everything up, and then the screws pull it all together in a way where it can't come apart. So we're going to be looking at how do we model up these part lines, what type of tolerances should we look at, and pretty much all of that. So there's not really too much more to talk about by looking at this. One thing though, when it comes to picking a controller we want to model up, like I was saying before, we do want to use something that's somewhat conventional. Something like this, probably a bit out there, because what we want to look at is our sculpt tools and how to build our skills using the sculpt tools. So, something like the Xbox 360 controller, you can see how easy, or not how easy, but how useful all of the sculpt tools would be when modeling something like this up. And then something like an old joystick is more for solid modeling, not so much the sculpt tool. And when we get to things like the Wii remote, like, that's essentially just a remote. We've got what was called the nunchuck. Definitely good for modeling it up. However, like Dustin and I found with the sunglasses project, when students veered off into more unconventional designs, the tools and skills we were learning may not cover all of it. So if you are going to go with something that's a bit weird or wacky, that might be on you. And I'm certainly happy for some of you to try and push it in terms of game control design, how you interact with it. But there's absolutely nothing wrong with going with something that's got 2 thumbsticks, 4 buttons, a D-pad, some triggers, and something like that. It's not so much the complexity of the controller that matters. What matters is how well you use the tools, how well you use the freeform sculpting and use it smart instead of just adding a bunch of lines and mushing it together to try and make it work. The simpler forms tend to show up best when it comes to actually rendering it. So the smarter you can model all of this up, the better it'll probably come out in the end. That's really it for now, just to talk about, basic controller design. There's, we don't have to go into advanced controller design for this. We're just modeling up forms. We're not trying to think about how someone's going to use this every day when they're playing Grand Theft Auto or whatever. So for now, and for our sort of context, we just need to understand that there's pretty much a top, a bottom, maybe a back plate as well. It can be split up in some interesting ways. We'll go over that a bit in class, and I'll provide other tutorials on that. But that's pretty much it for now. You should definitely download and then re-upload this to your Fusion to have a really good look at it. It'll be a great reference for when if you get stuck, you can say, oh, maybe I should make this thick or this big. Also, you don't have to take apart your own game controllers to figure out how all the grooves work.